Chapter 16.1, Solving Quadratic Equations Using Square Roots. All right, so we're finally here. We're actually going to start solving them. Remember that quadratic equations form what? When they're graphed. Remember, we still have graph, tables, and equations. So now these equations that we're dealing with, when we solve them, they're going to create a U shape called a parabola, okay? So we're first going to deal with the equation part of get, graph equations and tables, okay? Essential question of the day. How can you solve quadratic equations using what? Square roots. So this is more a square root type of lesson. I want to make sure that you understand how they're formed and what we can do with them and what we can't do with them. Okay, but we want to isolate the perfect square on one side of the equation by adding, subtracting, multiplying, or dividing. Those are our four operations. Then take the square root. Finally solve for both the positive and negative roots. Essentially, 4 steps. Vocab of the day. All right, so the product property of radicals. What is a radical? Well, we make that symbol, we call it a radical, and we're good to go. So naturally, we can change the different parts of this. Okay, so our index number, when it's not written, is what number? That's right, it's a 2. That's why we say square root. But can we change that? Yes, we can change it to a 3, 4, 5, whatever we want. Okay, so that is called the index, just so you understand that. But right now we're only going to deal with the square root of 2. So let's deal with that radical, okay? So the product property of radicals states that for a non-negative a or b, what can we do? The square root of a times b is equal to, and now we can split them apart. Square root of a times square root of b. So let's see that in action. Let's say that we had what? Let's say the square root of 8. I am allowed to break 8 down into its factors, which are what? 4 times 2. So we know something about that. If we split it, square root of 4 times square root of 2. Well, square root of 4 is a perfect square. Since 4 is a perfect square, I can take it out. What is that? 2 times 2. And let's delve into that. What am I talking about taking out? 4 is really what? 2 times 2. Since I have a pair, notice that our index is 2. In order for a number to come out, I need to have at least 2 of them here. So I can bring 1 to outside of the radical sign. So the square root of 4 is just a plain 2, which we get into plus or minus 2. But for the sake of argument, we bring out a 2. Notice though, in this square root 1, we only have 1 2. And since we don't have 2 of them, I cannot bring it outside of the radical sign. Therefore, it stays inside, and I keep it as 2 times, this says 2 times the square root of 2. Okay? Let's take something real simple. Square root of, let's say, 25. I really have what? 5 times 5. Do I have 2 of them? Yes, I do. So how many can I bring out? I can only bring 1 out. So the square root of 25 is equal to 5. Okay? And we can just keep going. Square root of 36. What is that equal to? We know that the index is 2. If it's not written, it's an automatic 2. Okay? If I break 36 down, I know it's a perfect square, 6 and 6. So I can bring out how many 6s? 1. So I get a 6. So the square root of 36 is 6. Now, it doesn't have to be a perfect square. I showed you that on the first one. What if it was 18? What can I break 18 down to? A 9 times what? 2. Well, That splits into square root of 9 times the square root of 2. So I can write the square root of 9 as what? 3 times 3. The other one is just a square root of 2. Do I have a pair? Yes. So I can bring a 3 out. Can I bring this 2 out? No. So you keep it inside and just leave it as is. So the square root of 18 in simplest form is 3 times square root of 2. The quotient property of radicals. Quotient meaning what? Yes, divide. Okay? So the quotient property of radicals states that for non-negative a or b, remember we're not dealing with negatives, okay? Because that's going to be a little different. Then I can say the square root of a divided by b is really the square root of a divided by the square root of b. What are they talking about? Let's say I have the square root of 36 and 100. Does that make sense? 36 divided by 100. I can have that underneath of there. Remember, since I didn't write the index, what is it? It's an automatic 2. But I can split this up and say the square root of 36 over the square root of 100, which now I go right back. 36 is really 6 times 6. 100 is really what? 10 times 10. And since I have a pair of 6's, I can pull one out, correct? So I can pull a 6 out. Since I have two 10's, I can pull one of the 10's out. And I'm able to get 6 divided by 10, which really, in simplest format, is what? 3 over 5. So the square root of 36 divided by 100 is 3/5. Square root of a negative number. I want to touch on this lightly because you might come up against something like this. But the square root of a negative number, let's say that it is the square root of -9. Immediately, all you have to do is say stop. At no point in time, now think about this, square roots. Square roots really say what? The same exact number multiplied together will result in a specific number. So 3 times 3 is what? 9. Notice that if I multiply two exact numbers, I will always get a what? Positive number. You're like, no, yes. -3 times -3 is what? Positive 9. 4 times 4, will a positive times a positive ever result in a negative number? No, it never will. But remember, even if I do a negative, it's the same number. I can't change it. So it has to be exactly the same. So -4 times -4 is still a what? Positive 16. So when you see a negative number inside of a radical, you're allowed to stop after a certain point. Okay? Does that make sense? And this is the point that you'll always stop. Remember, we're allowed to separate these. So I am going to call this -1 times what? 9. See how I removed the negative? I took it and made it all by itself. So I times it by a -1. You're allowed to split that up, right? So I get a -9 times a -1. And we know that the square root of 9 is just 3. Now this -1 really becomes something called an imaginary number. So the square root of -1 will always be something called I. Okay, so we get 3 times I. Simple as that. Now, before you sit there and go, what in the world are you talking about? Remember this rule. If I come along to a radical and there's a negative number in there, what should you do? Stop. We will talk about imaginary numbers later. Solving quadratic equations. We're finally there. Okay, so here we go. First things first, I just want to do this little simplification, make sure that you understand how to simplify. So square root of 16 is what? Don't forget, plus or minus 4. Square root of 25, what is it? Plus or minus 5. What's the square root of 50? Ooh. So you have to break it down. You have to go square root of 25 times the square root of what? 2. Now that I have that, I know that the square root of 25 is what? Plus or minus 5. Can I break down the square root of square root of 2 anymore? No. So I just leave it inside the radical. So I get plus or minus 5 square root of 2. You're allowed to have that answer. Okay? Which brings us to our quadratic equation. We're solving for what? X. Whenever we solve, what do we use? 4 steps. Simplify / combine like terms, anything to do? No. Remove all what? Addition, subtraction. So I'm going to add. So I add 4, add 4. I get x squared equals 4. Step 3, remove all multiplication and division from my variable. Well, my variable is the issue. I have x times an x. So how do I remove x times x? That's right. We are going to take the square root. So I take the square root of one side. What I do to one side, I must do to the other. So square root of x, square root of x squared is just plain old x. Remember, if I have a pair, how many can I pull out? 1. So I pull out x is equal to what? What's the square root of 4? Plus or minus 2. You get 2 answers. Don't think that you're just getting 1, okay? So you get 2 answers. It's plus or minus 2 because 2 times 2 works and negative 2 times negative 2 works, okay? So that's how you solve that. Example number 2, okay? So x squared minus 9 equals 0. Again, 4 steps, just solve for x. Simplify / combine like terms, nothing to do. Remove all what? Addition, subtraction. So I am going to add. So I add 9, add 9. What I do to one side, I must do to the other. So I get x squared equals 9. Remove all multiplication and division. Well, I'm multiplying x times x. How do I do the inverse of that? I have to take the square root, okay? So if I take the square root of x squared, take the square root of 9. That gets me what? It was x times x, right? So that's a pair. So I can pull out 1. So x equals plus or minus what? 3. 2 answers. Positive 3 and a negative 3. Special cases. So now if I have, let's say for instance, this x plus 5 squared equals 36 for step for solving for x. I want to do what first? Simplify / combine like terms. Can I simplify this? Yes. I notice that I have a perfect square here and I have a perfect square here. So what can I do? Immediately, I can take the square root of x plus 5 squared is equal to the square root of 36. Because what I do to one side, I must do to the other side. So here's a 2, here's a 2. They cancel each other out, right? So what am I left with? X plus 5. Well, you're probably like, what in the world, Mr. Harris? How'd you do that? Okay, let's just go back and do a quick review. If I have x plus 5 squared, what is that equal to? X plus 5 times x plus 5, correct? I have a pair. Now think about this. If I take the square root of this, that's like taking the square root of that, correct? And I can bring out a pair. So since I have a pair of x plus 5s, I can bring it from underneath the radical. What does that leave me? With x plus 5. So that's how we can simplify x plus 5 squared, okay? But what I do to one side, I must do to the other. Keep the laws equal, correct? So what is that equal to? What is the square root of 36? Well, again, I break it down. Square root of 36 is 6 times 6. Those are perfect. I have a pair, so I can bring out plus or minus 6. Does that make sense? Okay, plus or minus 6. Therefore, how many equations do I have right here? That's right, I have 2, and you have to get used to that. X plus 5 is equal to 6. X plus 5 is also equal to negative 6. Therefore, solve for X. Simplify / combine like terms, nothing to do. Remove addition and subtraction. I am going to subtract. Subtract what? 5. X is equal to 1. Simplify / combine like terms. Anything to do? No. Remove all addition and subtraction. Yes, I'm going to subtract. Subtract 5. Subtract 5. I get X is equal to negative 11. Now you're like, what in the world? How'd you do that? Okay. So let's just prove to ourselves that we actually have 2 different answers. So if I started off with x plus 5 squared equals 36. Well, I have 2 champions. I have a x equals 1 and I have a x equals negative 11. So let's prove, let's do the proof. Okay, let's prove that these are true. So let's substitute in what? 1. 1 plus 5 squared equals 36. 1 plus 5 is what? 6. 6 squared is what? 36. Is 36 equal to 36? Yes. So that checked out. Awesome. What was the other number that we had? Well, we had negative 11. So with negative 11, let's try it. Negative 11 plus 5 squared equals 36. Well, negative 11 plus 5 is what? Negative 6. Is negative 6 squared 36? Well, negative 6 times negative 6 is what? 36. So 36 is equal to 36. So it checks out. So the proof works. All you have to do, just coming back here, we can simplify things. If I see that they are perfect squares, I can take the square root of both sides, simplify it right off the bat, and therefore I get x plus 5 is equal to a plus or minus 6. Therefore, I'm going to get 2 answers. All right, example number 2. We have this x plus 9 is equal to 0. We're going to solve for what? X. So what do we do first? Simplify / combine like terms. Anything to do on your checklist? No. Step 2, remove all what? That's right, addition, subtraction. So I'm going to subtract. Subtract 9, subtract 9. What do you get? X squared is equal to negative 9. Step 3, remove all multiplication, division. Remember, I have x times x. So how do I get rid of a x times x? That is square root. If I take the square root on one side, I must take the square root on what? The other side. Therefore, I get what? X is equal to, and what did I say to do when you came up with the square root of a negative number? That's right. You stop. Whenever you come up to the square root of a negative number, you stop. Can't go any further than that, okay? Until we later teach you about imaginary numbers. Okay, practice problems of the day. Let's put it all together. So real world example, a contractor is building a fenced in area at a daycare. The area will be a rectangle. Let's draw that out. So here is our rectangle. Okay, so this is going to be the base. This is going to be the height. Okay, so the area will be a rectangle. Rectangle will be rectangular with the length of its base equal to half of the length of the height. So the height, do we know how big it is? No. So we write x. I don't know what it is. The base is going to be half of that height, correct? So really, this isn't drawn to scale. I should say that the height is bigger, correct? And this should be half. So if this is the height, I don't know what it is. I don't know the length. And this is the base, so it's going to be half of that distance. Okay? So that's more accurate according to what this problem is telling us. Okay? So how do I find the area of this rectangle? Well, area of a rectangle is area equals the base times the height. We already know that the area is equal to what? 5,000. So I can fill in 5,000 for area. The base is equal to what? 1/2 x. The height is equal to what? X. And now all we want to do is solve for x. Well, first things first. I'm going to actually flip these around so it looks the same. So I have 1/2 times what? X squared equals 5,000. Right? Because x times x is x squared, and I have a half. So let's go through solving our deal. Simplify / combine like terms. Anything to do? I can what? Remove fractions. We don't like fractions, so let's remove them. How do I remove a fraction? Yes, I only have one, so I have one denominator. So I can multiply both sides, that's why I put them in parentheses, by the what? Denominator. What I do to one side, I must do to the other. So I'm going to remove this fraction. So the 2's cancel out. Remember, this could be 2 over 1. So 2's cancel out. What am I left with? X squared is equal to, that's right, 10,000. So what do I do with that? Step 2. Any addition or subtraction? No. And is there multiplication and division? Yes, because it says x times x. But how do I remove that? That's right, square root. Okay, so I get x is equal to what? That's right, a plus or minus 100. So this is square root. Okay, all right, plus or minus 100. So now think about this. It's a fence. Can I have a negative distance? No. So it has to be what? A positive 100. And this is how we use that in a real world example. Okay?